Just for a little refresher, we've got an x plus 2 times an x plus 3, correct?
Yeah.
That's what this part here means? Okay? And that's going to give us an x squared plus 5x plus 6 in standard form. We already did this last unit, right? Now, I want you guys to practice finding both of those down here. Because before we do the next thing, I just need to make sure we're all back with it. All right? Same thing down there, please. You guys are going to help me out. I got an x minus 6 times an x minus 2, correct? Okay. So, what's x times x? Negative 6 times x. Negative 2 times x. And negative 2 times negative 6. So we're just going to point out, we've got the x squared again. We got these things combining. And we got that thing again. 4x squared minus 8x plus 12. Yeah. So the reason we're pointing this out is, first of all, there's some great benefits to the two different forms. This form tells me my y-intercept is 6, and my x-intercepts are negative 2 and negative 3. So if we can have both forms, we can get all intercepts, right? X-intercepts are 6 and 2, y-intercepts 12. So both forms, again, lets me get all the intercepts real quick. And that flexibility to go back and forth is really nice for that. So far, we've gone factored to standard quite a few times. Guess what we're going to start working on today then? Standard to factored. And it's like a puzzle, and with a little practice, it gets better and better, right? So the first couple we look at might not be like slam dunk, but just stay with it. So to build some big ideas, we already started doing these. We're going to practice that a little more. And what I want you to focus on is how you see that number happening over and over, and how you see that number happening over and over, okay? So look to establish a pattern for where those numbers are coming from over and over. So you're going to do, I don't care if you use the box method or not. We all know what James is doing. But you could choose to just distribute and see what's up too, okay? Either way. But you're going to see how they match, and you're going to look to make a general rule of what's happening over and over to make this number and this number. Look to form a general rule that's happening over and over to find this number and this number. All right? With your partners, let's go. I'm going to choose not to do the box method, but Mari, I'm actually going to jump. I think these ones are a little nicer up here. I guess let's start with the little nicer ones. The box method, we distribute, we get x squared plus 3x. In this term, we're going to be looking at in a moment. Here we distribute, we get x squared minus 6x. In this term, we're going to be looking at in a moment. What do you notice about the c term or the constant? Where is it on these?
At the end.
It's not there, right? There isn't one there. Okay, so that's how these two are going to be different. I'll box those ones. Those two are going to be a little different. So down here, when we distribute, we get x times x for x squared. We've got a 4x and 2x for what?
4x and 2x.
4x and 2x is a 6x. And a 2 times 4 for an 8. So Sam, what Mari was noticing then... Hey Sam, what Mari was noticing then is, it looked like when we added the numbers, we got this number. And when we multiplied them, we got this number. And I said, let's test that out and see if that's true. So over here, I've got my x squared for my x times x. And she said, add together the other numbers. That would be 14x. So would 10x and 4x make 14x? Yes. That actually checks out. Then for my c term, multiply 4 and 10, that's 40. Did that check out? Yeah. So it looks like we can add the two numbers to get my linear term and multiply them to get my constant term. I can add them together to get my linear, multiply to get my constant. And it's because of the box method, it is because of the distribution that it does work. It's like, you don't need to just memorize this thing works. It's because of the things you already know. Here's why we want this skill again. If I give you this, pretty easy to find the y-intercept, correct? What is it? 40. Okay? But if you don't have this, not easy to find the x-intercept with our tools. But if we can factor it, we can look up there what I just crossed off and see my -4 and -10. So that's another tool for the tool belt now. The flexibility. Now, it doesn't always work. Sometimes it works. So to have that flexibility to move back and forth, okay? So we're going to get a chance to practice this. We're going to do like 4 to 6 together first. Then I'm going to set you off on your own a little bit, okay? So you're going to want to get organized in your paper. Okay, we just talked about these, so I'll speed run this a little bit. These are the three terms, and I actually don't like looking at them like this. Yeah. Remember what this term's called? It's not up there right now. What's this term? Well, the number in front of it is a, but this term is called the quadratic term. Remember, how do we know it's the quadratic term? It's squared. This one's called what?
Linear.
Linear. It's like, see the slope? And this one's called constant, because it's just what it is. So that's review. We don't need to go through all these, but that's just review from the last unit. Here's where we're going to get to work for the rest of today, guys. So if this is factored form, we know how to distribute, so help me out. Ben, what's x times x? Okay, and then x times is 7, 7x. Again, we want this flexibility to say y-intercept is 0, x-intercept is 0, negative 7. Okay, this is where we're going to jump to a new thing, and this is where it's really important to have your notes. So in your notes right now, you should have this written down, x squared plus 9x. X squared plus 9x in your notes. So what form is that? Standard. It even says it up there, right? Okay, now we're going to try to get to factored form. So when it looks like this, we're looking to divide something out. So what's in common? What do both terms have the same? X. So I'm going to divide out an x. So to get x squared, what would I need to multiply x by? X. So I'm going to put that right there. And to get 9x, what would I have to multiply x by? 9. There's my factored form. And you can always check it by redistributing, right? Again, the reason we want this is y-intercept 0, x-intercept 0, negative 9. Okay? So just know that we factored out. So looking at the next one down, what's in common between x squared and negative 8x? X. So how do I get that x squared? X times x. And how do I get negative 8x? Minus, times negative 8. Again, y-intercept 0. The x-intercepts are 0 and 8. With the two forms, we can grab all the intercepts really fast because of the zero product property. Okay, this next one, let's try out a rule we established. I've got my x squared. What do I do with these numbers? What's been working every time when it's plus plus?
It's x squared plus 8x plus 12.
Well, how are we getting that 8x? What have we been doing with those numbers every time? Adding them. And then how are we getting that last number? By multiplying. So there's the standard form. We've done it before, right? You could, and don't be afraid, if you still need to do this, plus 6x plus 2x plus 12, don't be afraid to do that and combine like terms. I'm still fine with that. That extra step, it's fine. Now here's where we're going to get to the big new thing right now. You ready? I hope you're ready. I know that I want to get in factored form. How do I get my x squared? X times x. Remember, how am I getting that number? What operation? Adding, but on this number I'm getting multiplying. So what multiplies to 12? That's the question we ask ourselves. What multiplies to 12 but adds to be 13? 12 and 1. And if you're struggling to see that, don't be afraid to do this. Right, 1, 12, 2, 6, 3, 4, and look for the sum of 13. Don't be afraid to write out your pairs. So this has to be a 1 and a 12.
Does it have to be that number, or can it be like a different number?
Well, it can be x plus 12 times x plus 1, and it would still be good. But to multiply to be 12 but add to be 13, this is the only way. Okay? Okay? It's kind of like a puzzle. What multiplies to be the constant but adds to be the linear? I'm actually going to write that at the bottom. What multiplies to be constant but adds to be linear. That's like the little puzzle I do over and over. And if you don't remember that, ax squared plus bx plus c. Right here is my linear, right here's my constant. What multiplies to be constant but adds to be linear. So we can actually skip this one. Remember, we add to get the negative 8x and multiply to get the 12. Where you really want to focus your efforts, next up, you with your group, that set. All right? Make sure you make good mistakes. The mistake here is good. It's the first time we're doing it. So looking at our 12 here, one thing you can choose to do, write out the factors. Okay? Those are all the ways you can multiply nice to get to 12. What's going to get me to 7? Which pair?
X minus 3 and X minus 4.
The 3 and 4, right? So if it adds to be the negative but multiplies to be the positive, I'm looking at x minus 3 times x minus 4. Adds to be 7, multiplies to be 12.
Oh.
Nice. Huh? Yeah, because negative plus negative is a bigger negative. Negative times negative is a positive. And no, it doesn't have to be plus plus or minus minus. That's just what we're looking at today. So looking at 9, what are my factors I'd want to consider? 1 and 9, 3 and 3. Which one of those is going to get me to 6? Okay, so I have x plus 3 squared. Or you could write x plus 3 times x plus 3, you're good. Either way, it's the same. Okay? What did I say? We're going to do 3 of them? I want to do one more.
Do the last.
No, I'm going to do this one. So the 9s are 1, 9, 3, and 3. How am I going to get to 10?
-9 and -1.
And these ones have to be negative because they make a negative 10 for my linear term. Okay, I want you guys to finish these last two. Let's go. Let's go. So as I'm looking at it, I know I need an x times x for my x squared. I need a multiply to be 9, but add to be 10. What is it?
Plus 9 plus 1.
9 and 1, or 1 and 9. And again, I'm going to point out, the reason we want to be able to do that is now I can say y-intercepts 9, x-intercepts are -9 and -1. We can just look at it and get 3 points like that. Okay, last one. I know I need an x times x for my x squared. What multiplies to be 9 but adds to be -3?
-3 and
Sorry, -6. I just gave you the answer. Yeah. Or you can write it like this. Samesies. I'm not going to worry about that. I don't see advantage to doing that with you. Okay. So the big idea that you need to remember here is this. What multiplies to be the constant adds to be the linear. And now we can factor it. Now we have a tool in our tool belt, standard and factored form. We're looking at y-intercepts and x-intercepts by looking at it almost. All right? Better than guessing and checking, would you say? I think so. Okay, lesson summary. Show it to me to get your homework.